Hello, welcome to my YouTube channel. My name is Joseph, and in this video, I'll take you through how we are going to create a handwritten notes recognition artificial intelligence system. First of all, I must make you aware that students, writers, scholars, and all people engaged in writing, they all face a challenge of spending vast amounts of time converting their handwritten notes into soft copy, basically through typing to the keyboard. Now, in this way, we are going to create a solution to be able to alleviate this. Now, we are creating a handwriting notes recognition system. And now, handwritten recognition system, this refers to the computer's ability to detect and interpret characters which can be from various sources, such as touchscreen, paper documents, even drawings. Now, this AI system we are building shall be able to scan the handwritten notes and convert them into a digital format that can easily be altered every other way. You can edit it, you can format in every other ways that you can, all that you want. Yeah. Moving on now, type of data we're going to be using this system. Now, the system shall be trained on photographic image data. Now, this image data shall consist of images. Each image shall be a single character. Now, for each character shall have various images. The reason being that there are very many styles of the same character. And as you know, people have different handwritings. So this gives you different styles. And that's why we shall have to fit in same character, but very many images from different sources, different styles. So this is it. And besides that, you shall also have to hand in, to bring sketches or the hand-drawn diagrams sort of drawn into the system, and the system will be able to also be able to learn how to manage them and convert them into a digital format that's enhanced. Now, moving on, I'll give some of the difference between supervised and unsupervised learning. Now, just like the word supervised itself means I'm training you to do something by supervising. However, in unsupervised learning, you are learning to do something, but you're discovering the way to do things on your own. In other words, I'm not supervising you, there is no form of supervision. Now, these two concepts are applied to AI, and some of the differences are listed here below. Now, supervised learning algorithms are trained using labeled data, while unsupervised learning algorithms are trained using unlabeled data. This it means that supervised learning for the algorithms, you shall give it a predefined set data sets. For example, if you have X values mapping to Y values, so you're giving these values X and Y into the system. Well, for this case of the unsupervised learning, I'm simply getting the whole data set consisting of several data items, and I'm feeding into the system. Then the system should be able to find its own way of classifying them without me giving it a clue. Then the other difference is supervised learning model takes direct feedback to check if it is predicting correct output or not. And then for the unsupervised learning model, does not take any feedback. Moving on to the next difference, supervised learning model predicts the output, while the unsupervised learning model finds the hidden patterns in data. Now, this means that for the supervised learning model predicting the output, this means that I'll have given it some data, and then its part is either to group it in one of the already predefined groups. In other words, I'm saying if I give you this, let me say, a certain object or a certain color, but initially I'll pre-configure the system that there are two groups of colors, red or blue. Say, to test my system, I'm giving it a certain object, and then predicts from to which of the two colors they will belong. Or for the unsupervised learning, the model finds the hidden patterns in data. Yeah, so this means we're not predicting output, but our intention is giving you unlabeled data, and then this data define the patterns and then be able to give us a clue on this and then classify them accordingly. And the last difference here cited is in supervised learning, input data is provided to the model along with the output. Exactly, that's what I was talking about earlier on, that I provide you with an X and a Y value. So these two are being mapped. Yeah, then the unsupervised learning, only input data is provided to the model. Yeah, so we are saying we are giving this data set, this whole data set to the system, and the system is able to detect the patterns without giving it an output. So it finds for itself an output. Moving on, some of the supervised learning techniques we are going to use in our system are support vector machine, abbreviated SVM. Now, the SVM is based on the principle of structure risk minimization. And for our system, this shall be used in pattern recognition and classification of the character images. Or the other technique could be the K nearest neighbor, abbreviated KNN. Now, this shall be used for classification of the character image data based on how the neighbors are classified. By neighbors, I mean previously, okay, the character images previously been to the system. These would form clusters, and these would be the neighbors that we're talking about in reality. Now, it shall store all the available cases and classify new ones based on the similarity measure. Yeah, this is self-explanatory. Now, coming to the unsupervised learning techniques, we shall have a convolution neural network. And just like, neural networks, they try to mimic the neurons of the human brain. Now, this convolution neural network belongs to the category of multi-layer neural networks, and this shall mainly be used for image classification because of its capability of pattern detection, basically the convolution layer of the convolution neural network. Now, the other technique is the unsupervised learning. We shall have k-means clustering, and this is a method of vector quantization, and shall partition any observations of character images into k clusters, in which each observation belongs to the cluster with the nearest mean, serving as a prototype of the cluster in character recognition. Moving on, some of the AI technical challenges that we are likely to face in this project could be one, inaccurate or insufficient training data. Of course, there is the issue of a wide range of handwriting, good and bad. As we know, we come from different institutions. I mean, we started from different primary, secondary schools till we reached here at the university. So you find that people are having different handwritings. And some people, they are good, and in good, I mean, the characters are easily distinguishable, and in some others are bad. Of course, now this makes it tricky to provide enough examples of how every character might look. Hence, this leads to issues with accuracy of the system. The other technical challenge could be joined up handwriting. Of course, when your letters all connect, it makes it hard for the system to recognize individual characters. Now, considering an example, an R and N, if someone is writing an R and N and then they mix up or they combine the two, it would appear to be a letter M. Now, this will cause confusion in the system, and then whatever you're writing may not make any sense. Now, the other technical challenge could be awkward angles. Of course, in the case of handwriting recognition from photos, there are also awkward angles to consider. Now, the angle the photo is taken could obscure the character, making it harder for the computer to identify. Of course, this I think makes sense in its own way, you can see. Now, we're trying to alleviate some of these challenges, technical challenges already listed above. Now, I'll let you know that for computers to recognize and digitize handwritten documents and messages, there is a lot to learn. There are different letters, characters, and digits, but there is also need of being able to identify them despite the differences due to different handwriting styles. In this, I mean that however much you cited the other challenges, we cannot say that our system will fail because of them. No, we have to find a way of alleviating them. And this is where we are deploying deep learning and convolution neural networks. Now, deep learning allows machines to learn over time and adapt their output using weights. Moving on, I'll cite some of the differences in the metrics that we are considering. Now, there is a metric called accuracy. Now, accuracy is a measure of how many of the predictions are right and does not matter whether positive or negative. In this, I mean that I'm going to feed some data into my system having trained it. Then, after feeding this information, it will give me a bunch of positives and negatives. And then we shall have to actually to examine. Yes, the system says there are 9 positives, but how many in reality are among this, they said, okay, the system has said 9. How many among those 9 are truly positive? And then when it says these ones are negative, let's say there are 5. How many of these 5 are truly negative? So this is what we're talking about. So in general, the accuracy metric measures the ratio of correct predictions to the total number of instances evaluated. Now coming to recall as a metric, now recall is the proportion of real positive cases that are correctly predicted positive. Now recall is used to measure the fractional positive patterns that are correctly classified. Yeah, now this means that you're predicting, let's say there are 9, okay, the system, I've given it some data to test it, having trained it earlier. And so it will classify, we have 9 positives, that's the system's prediction. But you are saying how many true positives are within that set of 9 that the system has classified. This is what we call recall, yeah. And coming on to precision, now precision denotes the proportion of predicted positive cases that are correctly real positives. Exactly, as said earlier on. Now coming into F1 score. Now F1 score is a weighted average of the true positive. It's a weighted average of the true positive rate, which is of course in this case we're talking about recall and precision. Because this metric represents the harmonic mean between recall and precision value. Moving on, now some of the AI evaluation metrics we are considering for our system also shall be the mean square error, abbreviated MSE. Now, supervised learning vector quantization is one of the prototype selection classifiers. Now, during the learning process, supervised LVQ, as already abbreviated earlier, uses the mean square error to evaluate its performances during the classification training. In general, the mean square error measures the difference between the predicted solutions and the desired solutions. Now, a smaller mean square error value is required in order to obtain a better trained version of the supervised LVQ. LVQ means the learning vector quantization, as earlier depicted. Now, the other metric could be the character error rate, so dealing with character images. Now, the character error rate calculation is based on the concept of the Levenshtein distance, where we count the minimum number of character level operations required to transform the ground truth text into optical character recognition output. Now, Levenshtein distance is basically the distance metric measuring the difference between two string sequences. Moving on, we have the word error rate, abbreviated WER. Now, the word error rate is applicable as it involves the transcription of paragraphs and sentences of words with meaning, for example, pages of books, newspapers, and many others. Now, the word error rate operates at the word level instead. It represents the number of word substitutions, deletions, or insertions needed to transform one sentence into another, as you know. Now, these are some of the references to our work. As you can see, you can be able to follow them, and I'll give a link, some of these references in the description of the video down below. Just don't forget to hit the subscription button to receive updates always. Thanks for watching.